John. And the reason we chose the name Team Tetris is because each one of us represents a Tetronimo, and we have to work cohesively together to get our project done on time. And so to start out, this is our simple card design. It looks exactly the same as our original simple card design that we presented originally, but we actually flipped it. We flipped the orientation, so the 1.5-inch part was the tall part, and this allowed for better steering and for all of the components to fit inside better. And this is the underside. We hollowed it out on the mill, and then we created bottom plates where all of the components fit in, so the steering column and the motor and the charging and switch holes.
These are the simple wheels. As you can see, they are exactly the same dimensions of the original car, about 1-inch diameter. So you can use the rubber threads so they won't slip on the floor. And for the pattern, as I said, it's very, very simple. Just the oval circular figure that you need to rotate, and then just a few circles for decoration with a spot in the center to be manually drilled after it's been processed. And this was done in an array of about 24 in a linear from the 1/4-inch acrylic black plastic. And this is the complex design that John's going to talk about.
Lisa, will you explain a little bit more about the how we the car?
Okay, so Diego and I have this fascination with movie cars, and Sally Carrera is this particular character from the Pixar movie. It's actually modeled after Porsche 911. So
we tried to be, we were very strict with how we wanted the complex design to look like. So the same as the title says, complex, all the engineering process to design a machine that was in fact complex, and it took us a really long amount of time, which gets included in our fixed cost, but we get a ton of benefits out of it. First of all, this is the main body that we use, and as you can see, it doesn't just machine the top surface, but we also get a really good finish on the lower surface as well, so it actually looks like a real car. That makes our design much more eye-pleasing when you look at it first. It looks more like an actual car, and it will be more desirable for our customers. Then we also switch designs on how to put all the motors inside the complex design, because since we wanted to keep the shape of the car at all costs, we couldn't fit the motors in the usual position that in most part of the cars through the history of this class were using. So we redesigned the whole gear train so it would fit in a different way inside the car. So it goes perfectly straight, and that way we can fit absolutely everything there. We were very careful in doing all the tolerances here. So as you can see, there are places where exactly a capacitor is supposed to be. The inductors also carefully measured so it goes in one place. The motors and the under part of the main body are milled to write the exact dimensions, so that when you put these together, you don't even need glue to assemble it. We use some of it just to be safe, but all the components fit just as they are, and that also cuts us in variable cost, because we try to minimize in the material cost. We really spend a lot of in the fixed cost and the design, so that we didn't have to pay more in the fixed cost. We don't even use any screws. It's just the wheels, all the things that came inside of the cars that we were given, and the two black pieces that are made from the same material of the wheels. We don't use any piece of metal of the sheet of metal that we were provided, because that was one of our expensive parts as well. So we save a lot in variable cost that way as well. So these are the two pieces where the gears get in. These were the pieces where we made most of the mistakes of. All my team members wanted to kill me for the number of times I had to remake this because just this one would be shifted by 0.001 and then the gear train would not work. But at the end, they do fit nicely inside the cavity that we made. It provides the car with some steering capabilities that other cars out in the market will lack. We can make 360 degrees turns in less than the space of one of these square tiles. The other cars would need a very big radius, depending on how much they can steer. The down point is that the speed is reduced by a factor of 1.756 calculated. But that gives you more thinking time to decide how to steer it. We can keep the car at all times inside the track, so it is very maneuverable, and that's one of our pluses.
For the complex wheel design, as you can tell, it's a lot more intricate. It is actually modeled after a classic 911 Type 2 wheel provided in the real 911 Porsches nowadays. And you can see there's the classic pentagon figure that we try to convey in the simulated lug nut holes that work very nicely. This was a very long process. It took about 40 minutes, and it has matching front wheels that are slightly smaller due to how the car turns and maneuvers.
Okay, so the cycle times are the big factor for where our costs come from. Our designs are fairly complex, so that the simple design, even the car body, took 29 minutes. The chassis took 20 minutes to make enough for 6 cars. The wheels, 50 minutes to make enough wheels for 6 cars, and the stoppers, 20 minutes for 5 cars. The complex
What are
design.
stoppers?
Oh,
Go back to the first.
if you look at the truck, there are little circular pieces there.
So the stoppers
On the
work
front
in the
wheels.
following way.
What part of the stopper?
It's
Before
right
the
here.
wheels.
Oh,
when it
okay.
turns.
Yep.
What it does is, since this motor was intended to do complete revolutions, when it turns, the wheel hits the side of the car and prevents the wheel from spinning, so the car pretty much keeps going straight while it's turned. So the stoppers provide like a in-between, so that the stopper will hit the car, those will stop, but the wheels will keep spinning, providing you with steering.
Okay.
So the complex design took significantly longer. To machine the top and the bottom of the body, it took a total of 74 minutes. The chassis, those two little black pieces that John was talking about, those took 72 minutes to make 8. Enough for 8 cars, so a total of 16. And then the wheels took 55 minutes to make enough for 6 cars.
The chassis, what are you talking
Essentially those little black pieces where the gears all fit in.
Those are really close
He calls them
tolerances.
chassis.
about? I'm missing you here.
They're inside.
We'll
They're inside. The
explain
black
the
things.
questions
The
portion of
gear
the
casing.
Oh,
gear- yeah, the
I
black
see.
gear casings.
Okay, totally
Those
missed
super
that.
complex things we wanted to kill them for.
Yep.
That stuff. So the numbers are kind of scary right now. The materials we based on McMaster car.
Oh, can you go back one? So now that I understand
Cycle
what you're
times.
doing.
Yes.
Okay.
Do you have any other questions?
So your complex wheels were these? Oh, I see. Just a little bit more. Okay. Got it. Thanks.
Okay, so our production costs. Materials are based off of McMaster car, and we added about $6 for the electronics. The labor, we're assuming that we have one operator tending to both machines at the same time. So whichever the sum of the cycle time is greater. So in mill 3, we did the top and bottom of the body, and then in mill 2, we did all of the wheels and the chassis, and in the simple design case, the stoppers as well. All of that for mill 2 ended up being more of a cycle time, so we counted that for the labor cost. And we're assuming that the operator makes about